If you've been following developments in global aviation, you've probably heard about China's C919 aircraft. This narrow-body passenger jet has now been flying commercial routes for over a year, generating countless discussions across social media and aviation forums worldwide. Yet despite all the attention it has received, the vast majority of people still haven't had the chance to actually fly aboard one. But here's where the story takes an unexpected turn. In early February 2025, China made an announcement that sent ripples through the global aviation industry. The country revealed that another large passenger aircraft, one far more ambitious than the C919, is now preparing to enter its critical test flight phase. This aircraft is called the C929, and according to China's state-owned commercial aircraft corporation, known as COMAC, it represents something unprecedented. The first long-range, wide-body passenger jet developed entirely under Chinese leadership, built to meet international airworthiness standards, and protected by independent intellectual property rights. Let's put this into perspective. The C929 isn't just another regional aircraft. It's designed to carry 280 passengers across distances of up to 12,000 kilometers. That's roughly the distance from Beijing to London, or from Shanghai to Los Angeles. In other words, this is an intercontinental giant, purpose-built to compete directly with two of the most successful wide-body aircraft ever made: Boeing's 787 Dreamliner and Airbus's A350. When China announced that the C929 would soon begin test flights, media outlets in Germany and across Europe took notice. Several publications pointed out that Boeing and Airbus, the two undisputed titans of commercial aviation, are now staring at a new challenger. And not just any challenger, but one backed by the world's second-largest economy, a massive domestic market, and decades of accumulated aerospace ambition. So what makes the C929 so formidable? Why are Western aviation giants taking it seriously? And how did China go from being a latecomer in commercial aviation to developing an aircraft that could reshape the global market? Before we dive deeper, if you enjoy content like this, stories about technology, geopolitics, and the forces reshaping our world, please take a moment to subscribe to the channel. It helps us continue bringing you in-depth analysis on the topics that matter. Now, let's explore the full story of the C929. From the C919 to the C929, China's aviation ambitions take flight. China is now the third country in the world capable of independently designing and manufacturing large commercial aircraft, joining the United States and Europe in this exclusive club. The C919, which entered commercial service in 2023, marked a historic milestone. It demonstrated that China could build a competitive narrow-body airliner, breaking the duopoly that Boeing and Airbus had enjoyed for decades. But what many people don't realize is that even as the C919 was being developed, China was already planning something far more ambitious. The story of the C929 actually begins in 2015, several years before the C919 even took to the skies. At that time, China's experience in building wide-body aircraft was still limited. Wide-body planes are far more complex than their narrow-body counterparts. They require greater structural integrity, more powerful engines, advanced aerodynamics, and sophisticated systems integration. Recognizing these challenges, COMAC decided to pursue an international partnership. The partner China chose was Russia's United Aircraft Corporation, or UAC. Together, the two countries committed over $2 billion to jointly develop a next-generation wide-body aircraft. In 2016, they formalized their partnership with an official cooperation agreement, and the project was christened the CR929, the CR standing for China and Russia. According to the terms of this agreement, China would shoulder the financial investment, while Russia would contribute technical expertise, particularly in areas like engine design and advanced materials. China would also be responsible for final assembly, with the primary markets identified as China, Russia, and other parts of Asia. The vision was clear: combine China's growing manufacturing capabilities and design innovation with Russia's deep experience in aerospace engineering to create an aircraft that could go head-to-head with the Boeing 787. For a few years, the partnership progressed. Engineers from both countries collaborated on design specifications, aerodynamics, and systems architecture. But then, geopolitics intervened. A partnership unravels: Russia's exit and China's solo journey. In early 2021, tensions between Russia and Ukraine escalated dramatically, eventually erupting into a full-scale military conflict. The war had far-reaching consequences, not just for the countries directly involved, but for Russia's entire industrial base. As the conflict intensified, Russia began redirecting its technical workforce toward military production. Skilled engineers, technicians, and factory workers who had been working on civilian aerospace projects, including the C929, were reassigned to defense contractors. Projects that had been moving forward suddenly stalled. Deadlines were missed. Development milestones slipped. By 2021, the impact on the CR929 program became undeniable. Chinese research teams had been meeting their targets and achieving their development goals on schedule. But on the Russian side, progress had slowed significantly. Key components weren't being delivered. Technical consultations were delayed. The imbalance grew more pronounced with each passing month. In 2022, after months of mounting difficulties, Russia made the decision to officially withdraw from the CR929 project. The partnership that had once seemed so promising was effectively over. For many observers, this seemed like a devastating blow. Skeptics argued that without Russian technical support, especially in critical areas like engine development and material science, China would be unable to complete such an advanced aircraft on its own. After all, designing a long-range wide-body passenger jet is extraordinarily difficult, arguably more complex than developing a military transport aircraft. But China had a different plan. Rather than abandon the project, COMAC chose to press forward independently. The aircraft was renamed the C929, dropping the R that had stood for Russia. Interestingly, Russia didn't disappear from the project entirely. The country agreed to remain involved as a supplier, continuing to provide certain aircraft components. But the leadership, the design authority, and the development responsibility now rested entirely with China. And then, in February 2025, came the announcement that surprised many in the aviation industry. The C929 was ready to begin test flights. What makes the C929 different: size, range, and total independence? At first glance, some people assumed the C929 was simply a larger version of the C919, an incremental improvement rather than a revolutionary leap. But a closer examination reveals just how significant the differences really are. Let's start with the basics. The C919 is a narrow-body, single-aisle aircraft designed primarily for domestic and regional routes. It can carry 168 passengers and has a maximum range of approximately 4,000 kilometers. That makes it ideal for flights within China or to neighboring countries. Think Beijing to Shanghai or Shanghai to Tokyo. The C929 operates in an entirely different category. It's a wide-body, twin-aisle aircraft with seating for 280 passengers. Its maximum range is 12,000 kilometers, which means it can fly non-stop from Shanghai to London or from Beijing to New York. This isn't a regional hopper. It's a true intercontinental workhorse designed for the world's longest and most lucrative air routes. But perhaps the most significant difference lies in something less visible: self-reliance. When the C919 was developed, China relied heavily on international suppliers for critical components. Western companies provided the engines, avionics, landing gear, and other key systems. While this approach allowed China to get the C919 into service relatively quickly, it also created a vulnerability. The localization rate, the percentage of components made in China, stood at only about 60%. This gave Western governments leverage. If political tensions rose, they could restrict the supply of essential parts, effectively grounding China's aircraft. The C929 takes a fundamentally different approach. COMAC has prioritized indigenous development, aiming for a much higher degree of self-sufficiency. And nowhere is this more evident than in the engine. The CJ2000 engine, China's homegrown power plant. Jet engines are often described as the crown jewel of aerospace engineering, and honestly, that's for good reason. They represent some of the most complex machinery ever built, requiring expertise in thermodynamics, materials science, precision manufacturing, and systems integration. For decades, only a handful of companies worldwide have been able to produce high-performance commercial jet engines: General Electric, Rolls-Royce, Pratt & Whitney, and a few others. China has been working to join this exclusive club. The C929 will be powered by the CJ2000, a turbofan engine developed entirely in China. Originally, the CJ2000 was intended for the C919, but at the time, Chinese engineers determined that it hadn't yet achieved the necessary levels of reliability and safety for commercial service. So, the C919 launched with imported engines instead. But the development work on the CJ2000 continued, and now it's ready for its debut on the C929, with full-scale testing expected around 2029. Let's talk about what makes this engine remarkable. The CJ2000 produces 35 tons of thrust, which is actually more than the GNX engine used on the Boeing 787, which generates around 33 tons. The engine features a massive fan diameter of 3 meters and stands 4.55 meters tall. But raw power isn't the only story here. Efficiency matters just as much. According to Chinese aerospace authorities, the CJ2000 has a significantly lower fuel consumption rate during cruising compared to similar international engines. This translates directly into lower operating costs for airlines, which is one of the most important factors when choosing which aircraft to purchase. The engine is also designed to be remarkably quiet, meeting or even exceeding international noise regulations, a growing concern as airports around the world implement stricter environmental standards. As of February 2024, critical components of the CJ2000, including the fan drive gearbox, had successfully completed testing. Engineers have validated its performance across a range of operating conditions, from sea-level takeoff to high-altitude cruise. When you combine the CJ2000's performance characteristics, high thrust, low fuel consumption, reduced noise, with the C929's advanced aerodynamics and lightweight construction, you get an aircraft that can cruise at speeds of up to 980 kilometers per hour while maintaining excellent fuel efficiency. This is why aviation analysts in the West are paying attention. The C929 isn't just competitive on paper. It has the potential to offer airlines a compelling alternative to Boeing and Airbus, particularly in markets where cost efficiency is paramount. How does the C929 stack up? Let's take a technical deep dive. To truly understand the C929's potential impact, we need to compare it directly with its primary competitors, the Boeing 787 Dreamliner and the Airbus A350. Let's start with materials and construction. Modern aircraft increasingly use advanced composite materials instead of traditional aluminum. These composites, primarily carbon fiber, are lighter, stronger, and more resistant to fatigue and corrosion. The Boeing 787 was revolutionary in this regard, incorporating composites into approximately 50% of its structure. The C929 matches or even exceeds this. More than 50% of the aircraft's airframe consists of carbon fiber composites, reducing overall weight and improving fuel efficiency. Additionally, the C929 uses titanium alloy for about 15% of its structure, a higher proportion than most narrow-body aircraft, which typically use around 10%. This extensive use of advanced materials has earned the C929 the designation of a green commercial aircraft by Chinese authorities. For comparison, the C919 uses titanium for approximately 12% of its structure, so the C929 represents a measurable advancement in materials technology. Now let's talk about systems integration. The C929 incorporates 10 core systems that work together seamlessly. Avionics, communication and navigation, main and auxiliary hydraulic systems, wing high-lift systems, environmental control, electrical power, fuel management, and more. The aircraft features over 2.2 million individual parts and required the production of 3,500 test components during its development. One particularly advanced feature is the real-time monitoring system. This sophisticated network continuously tracks the aircraft's performance, structural health, engine parameters, and environmental conditions, feeding data to both the flight crew and ground-based maintenance teams. This kind of comprehensive monitoring enhances safety and allows airlines to practice predictive maintenance, addressing potential issues before they become serious problems. The cockpit itself reflects the latest thinking in human-machine interfaces. The C929's flight deck is equipped with an advanced avionics suite featuring large, high-resolution displays, intuitive controls, and adjustable lighting that can be customized by pilots. The seats offer multiple adjustment angles to reduce fatigue during long flights. Interestingly, 9 different suppliers contribute to the C929's avionics system, and 4 of them are Chinese companies. Shanghai Aviation Industry, one of China's leading aerospace firms, has taken on primary responsibility for major technical aspects of the avionics integration. Let's move to the wings, a critical element for any long-range aircraft. The C929's wingspan extends nearly 65 meters, which is actually wider than the Boeing 787's. Designing wings of this size involves extraordinarily complex engineering. The wing must be strong enough to support the aircraft's weight, flexible enough to handle turbulence and stress, and aerodynamically optimized to minimize drag while maximizing lift. Every meter of additional wingspan requires recalculation of countless variables: aerodynamic loads, material strength, flutter characteristics, lift-to-drag ratios. Engineers must conduct extensive wind tunnel testing and computational fluid dynamics simulations to ensure the wing performs safely and efficiently across all flight conditions, from takeoff to landing, from calm skies to severe weather. The payoff for this engineering investment becomes clear inside the cabin. The passenger experience, comfort that competes. For most travelers, the true measure of an aircraft isn't found in technical specifications, it's found in the experience of actually flying in it. The Boeing 787 Dreamliner earned its name partly through innovations in cabin comfort, larger windows, higher humidity, lower cabin altitude, and LED mood lighting. But one area where it has drawn criticism is seat spacing, particularly in economy class. After a 10 or 12-hour flight, many passengers report feeling cramped, with insufficient legroom and limited ability to stretch out. The C929 appears to have learned from this feedback. Its cabin width measures 5.5 meters, which is wider than both the Boeing 787, 5.28 meters, and the Airbus A350, 5.34 meters. This additional space can be used in various ways: wider seats, more comfortable armrests, wider aisles, or simply more breathing room in the cabin. For passengers, especially on long-haul flights, these seemingly small differences can significantly impact comfort. Airlines will ultimately decide how to configure the cabin, and they'll face the familiar trade-off between passenger comfort and seat density. But the C929 gives them more options to work with than its competitors. Beyond passenger comfort, there's another dimension where the C929 could prove highly competitive: operating economics. The economics of flight. Why airlines might choose the C929. When airlines decide which aircraft to purchase, they're making a calculation that goes far beyond sticker price. They're evaluating total cost of ownership over the aircraft's entire service life, typically 20 to 30 years. Key factors include fuel efficiency, maintenance costs, crew training requirements, spare parts availability, resale value, and of course the initial purchase price. The C929's extensive use of composite materials contributes directly to fuel savings. A lighter aircraft requires less energy to fly, which means burning less jet fuel. Over thousands of flights and millions of kilometers, these savings compound dramatically. But there's another factor that could give the C929 a significant edge: price competitiveness. Chinese manufactured products have historically been able to undercut Western competitors on price while maintaining acceptable quality levels. We've seen this pattern across industries, from consumer electronics to solar panels to high-speed trains. If COMAC can price the C929 significantly below the Boeing 787 and Airbus A350 while offering comparable performance, airlines operating on tight margins, particularly those in developing markets, will take notice. Lower aircraft costs could translate into lower ticket prices for passengers, making long-haul air travel more accessible to middle-class consumers in Asia, Africa, and Latin America. This democratization of air travel could open up enormous new markets. Of course, price alone won't determine the C929's success. Airlines also need assurance that the aircraft is safe, reliable, and supported by a robust global service network. This is where Boeing and Airbus currently hold major advantages. They've spent decades building relationships with airlines, establishing maintenance facilities, training thousands of technicians, and earning trust through proven performance. COMAC will need to build similar capabilities, and that won't happen overnight. But China has demonstrated its ability to play the long game, making patient investments that pay off years or decades later. The bigger picture: China's complete aviation ecosystem. The C929 doesn't exist in isolation. It's part of a comprehensive strategy to build a complete, end-to-end civil aviation industry in China. Consider the portfolio that's emerging. China's ARJ-21, a regional jet that once struggled for recognition, has recently been rebranded as the C909, signaling its integration into COMAC's unified product family. The C919 covers the narrow-body, single-aisle market. And now the C929 will address the wide-body, long-range segment. Together, these three aircraft types cover the vast majority of commercial aviation needs. An airline could, in theory, outfit its entire fleet with Chinese-made aircraft, from regional hops to intercontinental flights. But the ambition doesn't stop there. Industry observers and media reports suggest that COMAC has already begun preliminary design work on what might be called the C939, a potential competitor to even larger aircraft like the Boeing 777X or the Airbus A380. While specific details remain scarce, such an aircraft would likely feature even greater passenger capacity and longer range, designed for the world's busiest long-haul routes. And the vision extends even further into the future. According to some accounts, COMAC has outlined conceptual plans for an aircraft designated C949, envisioned as a supersonic passenger jet. This theoretical aircraft would feature revolutionary design elements, double-deck configuration, twin or perhaps even triple aisles, and most ambitiously, supersonic cruise capability. The timeline for these future projects is measured in decades, not years. According to COMAC's long-term strategic vision, by 2049, the centennial of the People's Republic of China, the country aims to become the global leader in commercial aviation technology. The goal is for China's domestic market to be supplied almost entirely by domestically produced aircraft. Is this realistic? Can China actually achieve technological leadership in commercial aviation within the next quarter century? The challenges ahead. What could go wrong? While China's progress in aviation is impressive, significant challenges remain. First, there's the question of international certification. Before the C929 can fly commercially outside of China, It needs to be certified by aviation authorities in other countries. Most importantly, the Federal Aviation Administration in the United States and the European Union Aviation Safety Agency. These regulatory bodies have stringent requirements and lengthy review processes. The C919 faced years of delays in obtaining Western certification, and the C929 will likely encounter similar obstacles. Second, there's the issue of supply chain resilience. Even though the C929 aims for greater self-reliance than the C919, it still relies on some international suppliers. If geopolitical tensions worsen, Western governments could impose sanctions or export restrictions on certain components, disrupting production. China is working to eliminate these vulnerabilities, but achieving complete supply chain independence for such a complex product is extraordinarily difficult. Third, there's the reputation factor. Boeing and Airbus have earned the trust of airlines through decades of reliable service. When an airline purchases a Boeing or Airbus aircraft, they're not just buying hardware. They're buying into a proven ecosystem of training, maintenance, support, and spare parts availability. COMAC is still building these capabilities, and some airlines may hesitate to bet their operations on a relatively unproven manufacturer, regardless of how impressive the specifications look on paper. Fourth, there's the matter of production capacity. Even if demand for the C929 proves strong, can COMAC manufacture the aircraft at scale? Boeing and Airbus have highly optimized production lines capable of delivering dozens of aircraft per month. Scaling up from prototype production to industrial-scale manufacturing is a challenge that has defeated many aerospace companies throughout history. Finally, there's the wild card of technological disruption. The aviation industry is facing growing pressure to reduce carbon emissions. Some experts believe that the future of long-haul aviation might involve hydrogen propulsion, electric hybrid systems, or radically different aircraft designs. If the industry shifts toward these alternative technologies faster than expected, the C929, with its conventional kerosene-burning engines, could find its market window narrower than anticipated. What this means for Boeing and Airbus: a new era of competition. For decades, Boeing and Airbus operated in what was effectively a comfortable duopoly. Airlines had only two real choices when purchasing large commercial aircraft, which gave both manufacturers significant pricing power and limited the incentive to innovate aggressively. The arrival of a credible third competitor changes this dynamic fundamentally. Boeing is already facing significant challenges. The company's reputation has been damaged by safety issues with the 737 MAX, production problems with the 787, and delays with the 777X. Its relationship with airline customers has been strained, and trust has eroded. The C929 arrives at a moment when Boeing is particularly vulnerable.